Welcome to the I Can't Sleep podcast, where I read random articles from across the web to bore you to sleep with my soothing voice. I'm your host, Benjamin Boster. Today's episode is from a Wikipedia article titled Mudbrick. A mudbrick is an air-dried brick made of a mixture of mud containing loam, clay, sand, and water, mixed with a binding material such as rice husks or straw. Mudbricks are known from 9000 BCE. From around 5000 to 4000 BCE, mudbricks evolved into fired bricks to increase strength and durability. Nevertheless, in some warm regions with very little timber available to fuel a kiln, mudbricks continued to be in use. Until today, mudbricks are the standard of vernacular architecture in some warmer regions, mainly in parts of Africa and Western Asia. In the 20th century, the compressed earth block was developed using high pressure as a cheap and eco-friendly alternative to obtain non-fired bricks with more strength than the simpler air-dried mud bricks. The history of mud brick production and construction in the southern Levant may be dated as far back to the pre-pottery Neolithic A, e.g. PPNA Jericho. These sun-dried mud bricks, also known as adobe or just mud brick, were made from a mixture of sand, clay, water, and frequently tempered, e.g. chopped straw and chaff branches, and were the most common method or material for constructing earthen buildings throughout the ancient Near East for millennia. Unfired mud brick is still made throughout the world today using both modern and traditional methods. The 9000 BCE dwellings of Jericho were constructed from mud bricks, affixed with mud, as would those at numerous sites across the Levant over the following millennia. Well-preserved mud bricks from a site at Tel Saf in the Jordan Valley have been dated to 5200 BCE, though there is no evidence that either site was the first to use the technology. Evidence suggests that the mud brick composition at Tel Saf was stable for at least 500 years throughout the Middle Chalcolithic period. The South Asian inhabitants of Mehrgar constructed and lived in mud brick houses between 7000 to 3300 BCE. Mud bricks were used at more than 15 reported sites attributed to the 3rd millennium BCE in the ancient Indus Valley civilization. In the mature Harappan phase, fired bricks were used. The Mesopotamians used sun-dried bricks in their city construction. Typically, these bricks were flat on the bottom and curved on the top, called plano-convex mud bricks. Some were formed in a square mold and rounded so that the middle was thicker than the ends. Some walls had a few courses of fired bricks from their bases up to the splash line to extend the life of the building. In Minoan, Crete, at the Knossos site, there is archaeological evidence that sun-dried bricks were used in the Neolithic period, prior to 3400 BCE. Sun-dried mud brick was the most common construction material employed in ancient Egypt during Pharaonic times, and were made in pretty much the same way for millennia. Mud from the same locations required sand, chopped straw, or other binders such as animal dung to be mixed in with the mud to increase durability and plasticity. Workers gathered mud from the Nile River and poured it into a pit. Workers then tramped on the mud while straw was added to solidify the mold. The mud bricks were chemically suitable as fertilizer, leading to the destruction of many ancient Egyptian ruins, such as Edfu. A well-preserved site is Amarna. Mud brick use increased at the time of Roman influence. In the ancient Greek world, mud brick was commonly used for the building of walls, fortifications, and citadels, such as the walls of the citadel of Troy, Troy II. These mud bricks were often made with straw or dried vegetable matter. In areas of Spanish influence, mud brick construction is called adobe, and developed over time into a complete system of wall protection, flat roofing, and finishes, which in modern English usage is often referred to as adobe style, regardless of the construction method. The Great Mosque of Janneh in central Mali is the world's largest mud brick structure. It, like much of Sahelian architecture, is built with a mud brick called banco, a recipe of mud and grain husks, fermented, and either formed into bricks or applied on surfaces as a plaster-like paste in broad strokes. This plaster must be reapplied annually. In some cases, brickmakers extended the life of mud bricks by putting fired bricks on top or covering them with stucco. A brick is a type of construction material used to build walls, pavements, and other elements in masonry construction. Properly, the term brick denotes a unit primarily composed of clay, but is now also used informally to denote units made of other materials or other chemically cured construction blocks. Bricks can be joined using mortar, adhesives, or by interlocking. Bricks are usually produced at brickworks in numerous classes, types, materials, and sizes, which vary with region and are produced in bulk quantities. Block is a similar term referring to a rectangular building unit composed of clay or concrete, but is usually larger than a brick. Lightweight bricks, also called lightweight blocks, are made from expanded clay aggregate. Fired bricks are one of the longest lasting and strongest building materials, sometimes referred to as artificial stone and have been used since circa 4000 BC. Air-dried bricks, also known as mud bricks, have a history older than fired bricks and have an additional ingredient of a mechanical binder such as straw. Bricks are laid in courses and numerous patterns known as bonds, collectively known as brickwork, and may be laid in various kinds of mortar to hold the bricks together to make a durable structure. The earliest bricks were dried mud bricks, meaning that they were formed from clay-bearing earth or mud and dried, usually in the sun, until they were strong enough for use. The oldest discovered bricks, originally made from shaped mud and dating from before 7500 BC, were found at Tel Aswad in the upper Tigris region and in southeast Anatolia, close to Diyarbakir. Mud brick construction was used at Catalyuk from about 7400 BC. Mud brick structures dating to around 7200 BC have been located in Jericho, Jordan Valley. These structures were made up of the first bricks with dimensions 400 by 150 by 100 millimeters. Between 5000 and 4500 BC, Mesopotamia had discovered fired brick. The standard brick sizes in Mesopotamia followed a general rule. The width of the dried or burned brick would be twice its thickness, and its length would be double its width. The South Asian inhabitants of Mehrgar also constructed air-dried mud brick structures between 7000 and 3300 BC. And later the ancient Indus Valley cities of Mohenjo-Daro, Harappa, and Mehrgar. Ceramic or fired brick was used as early as 3000 BC in early Indus Valley cities like Kalibangan. In the middle of the 3rd millennium BC, there was a rise in monumental baking brick architecture in Indus cities. Examples included the Great Bath at Mohenjo-Daro, the fire altars of Kalibangan, and the granary of Harappa. There was a uniformity to the brick sizes throughout the Indus Valley region, conforming to the 1 to 2 to 4 thickness, width, and length ratio. As the Indus civilization began its decline at the start of the 2nd millennium BC, Harappans migrated east, spreading their knowledge of brick-making technology. This led to the rise of cities like Pataliputra, Kausambi, and Ujjain. where there was an enormous demand for kiln-made bricks. By 604 BC, bricks were the construction materials for architectural wonders, such as the Hanging Gardens of Babylon, where glazed fired bricks were put into practice. The earliest fired bricks appeared in Neolithic China around 4400 BC at Chengtaoshan, a walled settlement of the Daxi culture. These bricks were made of red clay, fired on all sides to above 600 degrees Celsius, and used as flooring for houses. By the Qialing period, 3300 BC, fired bricks were being used to pave roads and as building foundations at Chengtaoshan. According to Lucas Nicol, the use of ceramic pieces for protecting and decorating floors and walls dates back at various culture sites to 3000 to 2000 BC, and perhaps even before, but these elements should be rather qualified as tiles. For the longest time, builders relied on wood, mud, and rammed earth, while fired brick and mud brick played no structural role in architecture. Proper brick construction for erecting walls and vaults finally emerges in the 3rd century BC, when baked bricks of regular shape began to be employed for vaulting underground tombs. Hollow brick tomb chambers rose in popularity as builders were forced to adapt due to a lack of readily available wood or stone. The oldest extant brick building above ground is possibly Songyu Pagoda, dated to 523 AD. By the end of the 3rd century BCE in China, both hollow and small bricks were available for use in building walls and ceilings. Small fired bricks were first mass-produced during the construction of the tomb of China's first emperor, Qin Shi Huangdi. The floors of the 3 pits of the terracotta army were paved with an estimated 230,000 small bricks, with the majority measuring 28 by 14 by 7 centimeters, following a 4:2:1 ratio. The use of fired bricks in Chinese city walls first appeared in the Eastern Han Dynasty, 25 AD to 220 AD. Up until the Middle Ages, buildings in Central Asia were typically built with unbaked bricks. It was only starting in the 9th century CE when buildings were entirely constructed using fired bricks. The Carpenter's Manual, Yingxiao Fashi, published in 1103 at the time of the Song Dynasty, described the brick-making process and glazing techniques then in use. Using the 17th century encyclopedic text, Jiangang Kaiyu, historian Timothy Brooke outlined the brick production process of Ming Dynasty China. The kiln master had to make sure that the temperature inside the kiln stayed at a level that caused the clay to shimmer with the color of molten gold or silver. He also had to know when to quench the kiln with water so as to produce the surface glaze. To anonymous laborers fell the less skilled stages of brick production, mixing clay and water, driving oxen over the mixture to trample it into a thick paste, scooping the paste into standardized wooden frames to produce a brick roughly 42 centimeters long, 20 centimeters wide, and 10 centimeters thick, smoothing the surfaces with a wire-strung bow, removing them from the frames, printing the fronts and backs with stamps that indicated where the bricks came from and who made them, loading the kilns with fuel, likelier wood than coal, stacking the bricks in the kiln, removing them to cool while the kilns were still hot, and bundling them into pallets for transportation. It was hot, filthy work. Early civilizations around the Mediterranean, including the ancient Greeks and Romans, adopted the use of fired bricks. By the early 1st century CE, standardized fired bricks were being heavily produced in Rome. The Roman legions operated mobile kilns and built large brick structures throughout the Roman Empire, stamping the bricks with the seal of the legion. The Romans used brick for walls, arches, forts, aqueducts, etc. Notable mentions of Roman brick structures are the Herculean Gate of Pompeii and the Baths of Caracalla. During the early Middle Ages, the use of bricks in construction became popular in Northern Europe, after being introduced there from northwestern Italy. An independent style of brick architecture known as brick Gothic, similar to Gothic architecture, flourished in places that lacked indigenous sources of rocks. Examples of this architectural style can be found in modern-day Denmark, Germany, Poland, and Kaliningrad, former East Prussia. This style evolved into the brick Renaissance as the stylistic changes associated with the Italian Renaissance spread to Northern Europe, leading to the adoption of Renaissance elements into brick building. Identifiable attributes include a low-pitched, hipped or flat roof, symmetrical facade, round arch entrances and windows, columns and pilasters, and more. A clear distinction between the two styles only developed at the transition to Baroque architecture. In Lübeck, for example, brick Renaissance is clearly recognizable in buildings equipped with terracotta reliefs by the artist Statius von Dieren, who was also active at Schwerin Castle, and Wismar, Fürstendorf. Long-distance bulk transport of bricks and other construction equipment remained prohibitively expensive until the development of modern transportation infrastructure, with the construction of canal, roads, and railways. Production of bricks increased massively with the onset of the Industrial Revolution and the rise in factory building in England. For reasons of speed and economy, bricks were increasingly preferred as building material to stone, even in areas where the stone was readily available. It was at this time in London that bright red brick was chosen for construction to make the buildings more visible in the heavy fog and to help prevent traffic accidents. The transition from the traditional method of production known as hand molding to a mechanized form of mass production slowly took place during the first half of the 19th century. Possibly the first successful brick-making machine was patented by Henry Clayton, employed at the Atlas Works in Middlesex, England in 1855, and was capable of producing up to 25,000 bricks daily with minimal supervision. His mechanical apparatus soon achieved widespread attention after it was adopted for use by the Southeastern Railway Company for brick-making at their factory near Folkestone. The Bradley and Craven Ltd. Stiff plastic brick-making machine was patented in 1853, apparently predating Clayton. Bradley and Craven went on to be a dominant manufacturer of brick-making machinery. Predating both Clayton and Bradley and Craven Ltd., however, was the brick-making machine patented by Richard A. Fairfallen of Haverstraw, New York, in 1852. At the end of the 19th century, the Hudson River region of New York State would become the world's largest brick manufacturing region, with 130 brickyards lining the shores of the Hudson River, from Mechanicsville to Haverstraw, and employing 8,000 people. At its peak, about 1 billion bricks were produced a year, with many being sent to New York City for use in its construction industry. The demand for high office building construction at the turn of the 20th century led to a much greater use of cast and wrought iron, and later steel and concrete. The use of brick for skyscraper construction severely limited the size of the building. The Monadnock Building, built in 1896 in Chicago, required exceptionally thick walls to maintain the structural integrity of its 17 stories. Following pioneering work in the 1950s at the Swiss Federal Institute of Technology and the Building Research Establishment in Watford, UK, the use of improved masonry for the construction of tall structures up to 18 stories high was made viable. However, the use of brick has largely remained restricted to small to medium-sized buildings, as steel and concrete remain superior materials for high-rise construction. Bricks are often made of shale, because it easily splits into thin layers. 4 basic types of brick are unfired, fired, chemically set bricks, and compressed earth blocks. Each type is manufactured differently for various purposes. Unfired bricks, also known as mud bricks, are made from a mixture of silt, clay, sand, and other earth materials like gravel and stone, combined with tempers and binding agents such as chopped straw, grasses, tree bark, or dung. Since these bricks are made up of natural materials and only require heat from the sun to bake, mud bricks have a relatively low embodied energy and carbon footprint. The ingredients are first harvested and added together, with clay content ranging from 30 to 70%. The mixture is broken up with hoes or adzes and stirred with water to form a homogeneous blend. Next, the tempers and binding agents are added in a ratio, roughly 1 part straw to 5 parts earth to reduce weight and reinforce the brick by helping reduce shrinkage. However, additional clay could be added to reduce the need for straw, which would prevent the likelihood of insects deteriorating the organic material of the bricks, subsequently weakening the structure. These ingredients are thoroughly mixed together by hand or by treading and are then left to ferment for about a day. The mix is then kneaded with water and molded into rectangular prisms of a desired size. Typically, longer drying times are preferred, but the average is 8 to 9 days, spanning from initial stages to its application in structures. Unfired bricks could be made in the spring months and left to dry over the summer for use in the fall. Mud bricks are commonly employed in arid environments to allow for adequate air drying. Fired bricks are burned in a kiln, which makes them durable. Modern fired bricks are formed in one of 3 processes: soft mud, dry press, or extruded. Depending on the country, either the extruded or soft mud method is the most common, since they are the most economical. Clay and shale are the raw ingredients in the recipe for a fired brick. They are the product of thousands of years of decomposition and erosion of rocks, such as pegmatite and granite, leading to a material that has properties of being highly chemically stable and inert. Within the clays and shales are the materials of aluminosilicate, pure clay, free silica, quartz, and decomposed rock. One proposed optimal mix is 1 silica sand, 50% to 60% by weight, 2 alumina clay, 20% to 30% by weight, 3 lime, 2 to 5% by weight, iron oxide, less than or equal to 7% by weight, magnesia, less than 1% by weight. 3 main methods are used for shaping the raw materials into bricks to be fired. Molded bricks. These bricks start with raw clay, preferably in a mix with 25 to 30% sand to reduce shrinkage. The clay is first ground and mixed with water to the desired consistency. The clay is then pressed into steel molds with a hydraulic press. The shaped clay is then fired, burned, at 900 to 1,000 degrees Celsius to achieve strength. Dry pressed bricks. The dry press method is similar to the soft mud molded method, but starts with a much thicker clay mix, so it forms more accurate, sharper-edged bricks. The greater force and pressing and the longer burn make this method more expensive. Extruded bricks. For extruded bricks, the clay is mixed with 10 to 15% water, stiff extrusion, or 20 to 25% water, soft extrusion, in a pug mill. This mixture is forced through a die to create a long cable of material of the desired width and depth. This mass is then cut into bricks of the desired length by a wall of wires. Most structural bricks are made by this method, as it produces hard, dense bricks, and suitable dies can produce perforations as well. The introduction of such holes reduces the volume of clay needed, and hence the cost. Hollow bricks are lighter and easier to handle, and have different thermal properties from solid bricks. The cut bricks are hardened by drying for 20 to 40 hours at 50 to 150 degrees Celsius before being fired. The heat for drying is often waste heat from the kiln. In many modern brickworks, bricks are usually fired in a continuously fired tunnel kiln, in which the bricks are fired as they move slowly through the kiln on conveyors, rails, or kiln cars, which achieves a more consistent brick product. The bricks often have lime, ash, and organic matter added, which accelerates the burning process. The other major kiln type is the Bowles Trench Kiln, BTK, based on a design developed by British engineer W. Bowl in the late 19th century. An oval or circular trench is dug 6 to 9 meters wide, 2 to 2.5 meters deep, and 100 to 150 meters in circumference. A tall exhaust chimney is constructed in the center. Half or more of the trench is filled with green, unfired bricks, which are stacked in an open lattice pattern to allow airflow. The lattice is capped with a roofing layer of finished brick. In operation, new green bricks, along with roofing bricks, are stacked at one end of the brick pile. Historically, a stack of unfired bricks covered for protection from the weather was called a hack. Cooled finished bricks are removed from the other end for transport to their destinations. In the middle, the brick workers create a firing zone by dropping fuel, coal, wood, oil, debris, etc., through access holes in the roof above the trench. The constant source of fuel may be grown on the woodlots. The advantage of the BTK design is a much greater energy efficiency compared with clamp or stove kilns. Sheet metal or boards are used to route the airflow through the brick lattice so that fresh air flows first through the recently burned bricks, heating the air, then through the active burning zone. The air continues through the green brick zone, preheating and drying the bricks, and finally out the chimney where the rising gases create suction that pulls air through the system. The reuse of heated air yields savings in fuel cost. As with the rail process, the BTK process is continuous. A half-dozen laborers working around the clock can fire approximately 15,000 to 25,000 bricks a day. Unlike the rail process, in the BTK process, the bricks do not move. Instead, the location at which the bricks are loaded, fired, and unloaded gradually rotate through the trench. The color of fired clay bricks is influenced by the chemical and mineral content of the raw materials, the firing temperature, and the atmosphere in the kiln. For example, pink bricks are the result of a high iron content. White or yellow bricks have a higher lime content. Most bricks burn to various red hues. As the temperature is increased, the color moves through dark red, purple, and then to brown or gray at around 1300 degrees Celsius. The names of bricks may reflect their origin and color, such as London stock brick and Cambridgeshire white. Brick tinting may be performed to change the color of bricks to blend in areas of brickwork with the surrounding masonry. An impervious and ornamental surface may be laid on brick either by salt glazing, in which salt is added during the burning process, or by the use of a slip, which is a glazed material into which the bricks are dipped. Subsequent reheating in the kiln fuses the slip into a glazed surface integral with the brick base. Chemically set bricks are not fired, but may have the curing process accelerated by the application of heat and pressure in an autoclave. Calcium silicate bricks are also called sand lime or flint lime bricks, depending on their ingredients. Rather than being made with clay, They are made with lime, binding the silicate material. The raw materials for calcium silicate bricks include lime mixed in a proportion of about 1 to 10 with sand, quartz, crushed flint, or crushed siliceous rock with mineral colorants. The materials are mixed and left until the lime is completely hydrated. The mixture is then pressed into molds and cured in an autoclave for 3 to 14 hours to speed the chemical hardening. The finished bricks are very accurate and uniform, although the sharp arises need careful handling to avoid damage to brick and brick layer. The bricks can be made in a variety of colors. White, black, buff, and gray blues are common, and pastel shades can be achieved. This type of brick is common in Sweden as well as Russia and other post-Soviet countries, especially in houses built or renovated in the 1970s. A version known as fly ash bricks, manufactured using fly ash, lime, and gypsum, known as the Foul G process, are common in South Asia. Calcium silicate bricks are also manufactured in Canada and the United States, and meet the criteria set forth in the ASTM C73-10 standard specification for calcium silicate brick, sand lime brick. Bricks formed from concrete are usually termed as blocks or concrete masonry unit and are typically pale gray. They are made from a dry, small aggregate concrete, which is formed in steel molds by vibration and compaction in either an egg layer or static machine. The finished blocks are cured rather than fired using low-pressure steam. Concrete bricks and blocks are manufactured in a wide range of shapes, sizes, and face treatments, a number of which simulate the appearance of clay bricks. Concrete bricks are available in many colors and as an engineering brick made with sulfate-resisting Portland cement or equivalent. When made with adequate amount of cement, they are suitable for harsh environments such as wet conditions and retaining walls. They are made to standards BS 6073, EN 771-3, or ASTM C55. Concrete bricks contract or shrink, so they need movement joints every 5 to 6 meters, but are similar to other bricks or similar density in thermal and sound resistance and fire resistance. Compressed earth blocks are made mostly from slightly moistened local soils compressed with a mechanical hydraulic press or manual lever press. A small amount of cement binder may be added, resulting in a stabilized compressed earth block. There are thousands of types of bricks that are named for their use, size, forming method, origin, quality, texture, and or materials. Categorized by manufactured method. Extruded, made by being forced through an opening in a steel die with a very consistent size and shape. Wire cut, cut to size after extrusion with a tensioned wire which may leave drag marks. Molded, shaped in molds rather than being extruded. Machine molded, clay is forced into molds using pressure. Handmade, clay is forced into molds by a person. Dry pressed, similar to soft mud method, but starts with a much thicker clay mix and is compressed with great force. Categorized by use. Common or building, a brick not intended to be visible, used for internal structure. Face, a brick used on exterior surfaces to present a clean appearance. Hollow, not solid. The holes are less than 25% of the brick volume. Perforated, holes greater than 25% of the brick volume. Keyed, indentations in at least one face and end to be used with rendering and plastering. Paving, brick intended to be in ground contact as a walkway or roadway. Thin, brick with normal height and length, but thin width to be used as veneer. Specialized use bricks. Chemically resistant. Bricks made with resistance to chemical reactions. Acid brick. Acid-resistant bricks. Engineering. A type of hard, dense brick used where strength, low water porosity, or acid, flue gas, resistance are needed. Further classified as Type A and Type B based on their comprehensive strength. Accrington. A type of engineering brick from England. Fire or refractory. Highly heat-resistant bricks. Clinker. A vitrified brick. Ceramic glazed. Fire bricks with a decorative glazing. Bricks named for place of origin. Chicago common brick. A soft brick made near Chicago, Illinois with a range of colors like buff yellow, salmon pink, or deep red. Cream City brick. A light yellow brick made in Milwaukee, Wisconsin. Dutch brick. A hard light-colored brick originally from the Netherlands. Fareham red brick. A type of construction brick. London stock brick. Type of handmade brick which was used for the majority of building work in London and southeast England until the growth in the use of machine-made bricks. Nanak Shahi bricks. A type of decorative brick in India. Roman brick. A long, flat brick typically used by the Romans. Staffordshire blue brick. A type of construction brick from England. For efficient handling and laying, bricks must be small enough and light enough to be picked up by the bricklayer using one hand, leaving the other hand free for the trowel. Bricks are usually laid flat, and as a result, the effective limit on the width of a brick is set by the distance which can conveniently be spanned between the thumb and fingers of one hand, normally about 100 millimeters. In most cases, the length of a brick is twice its width, plus the width of a major joint, about 200 millimeters or slightly more. This allows bricks to be laid bonded in a structure, which increases stability and strength. The wall is built using alternating courses of stretchers, bricks laid longways, and headers, bricks laid crossways. The headers tie the wall together over its width. In fact, a wall is built in a variation of English bond called English cross bond, where the successive layers of stretchers are displaced horizontally from each other by half a brick length. In true English bond, the perpendicular lines of the stretcher courses are in line with each other. A bigger brick makes for a thicker and thus more insulating wall. Historically, this meant that bigger bricks were necessary in colder climates, while a smaller brick was adequate and more economical in warmer regions. A notable illustration of this correlation is the Green Gate in Gdansk, built in 1571 of imported Dutch brick, too small for the colder climate of Gdansk. It was notorious for being a chilly and drafty residence. Nowadays, this is no longer an issue, as modern walls typically incorporate specialized insulation materials. The correct brick for a job can be selected from a choice of color, surface texture, density, weight, absorption, and pore structure, thermal characteristics, thermal and moisture movement, and fire resistance. In England, the length and width of the common brick remained fairly constant from 1625, when the size was regulated by statute at 9 by 4.5 by 3 inches. But the depth has varied from about 2 inches or smaller in earlier times to about 2.5 inches more recently. In the United Kingdom, the usual size of a modern brick is 250 millimeters by 102.5 millimeters by 65 millimeters, which, with a nominal 10 millimeters mortar joint, forms a unit size of 225 by 112.5 by 75 millimeters for a ratio of 6:3:2. In the United States, modern standard bricks are specified for various uses. The most commonly used is the modular brick and has the actual dimensions of 7 5/8 by 3 5/8 by 2 1/4 inches. The standard 3/8 inch mortar joint, this gives the nominal dimensions of 8 by 4 by 2 2/3 inches, which eases the calculation of the number of bricks in a given wall. The 2-to-1 ratio of modular bricks means that when they turn corners, a 1/2 running bond is formed without needing to cut the brick down or fill the gap with a cut brick. And the height of modular bricks means that a soldier course matches the height of 3 modular running courses, or 1 standard CMU course. Some brick makers create innovative sizes and shapes for bricks used for plastering, and therefore not visible on the inside of the building, where their inherent mechanical properties are more important than their visual ones. These bricks are usually slightly larger, but not as large as blocks, and offer the following advantages. A slightly larger brick requires less mortar and handling, fewer bricks, which reduces cost. Their ribbed exterior aids plastering. More complex interior cavities allow improved insulation, while maintaining strength. Blocks have a much greater range of sizes. Standard coordinating sizes in length and height in millimeters include 400 by 200, 450 by 150, 450 by 200, 450 by 225, 450 by 300, 600 by 150, 600 by 200, and 600 by 225. Depths, work size in millimeters, include 60, 75, 90, 100, 115, 140, 150, 190, 200, 225, and 250. They are usable across this range as they are lighter than clay bricks. The density of solid clay bricks is around 2,000 kilograms per meter cubed. This is reduced by frogging, hollow bricks, and so on. But aerated autoclaved concrete, even as a solid brick, can have densities in the range of 450 to 850 kilograms per meter cubed. Bricks may also be classified as solid, less than 25% perforations by volume, although the brick may be frogged, having indentations on one of the longer faces, perforated, containing a pattern of small holes through the brick, removing no more than 25% of the volume, cellular, containing a pattern of holes, removing more than 20% of the volume, but closed on one face, or hollow, containing a pattern of large holes, removing more than 25% of the brick's volume. Blocks may be solid, cellular, or hollow. The term frog can refer to the indentation or the implement used to make it. Modern brick makers usually use plastic frogs, but in the past they were made of wood. The compressive strength of bricks produced in the United States ranges from about 7 to 103 megapascals, varying according to the use to which the brick are to be put. In England, clay bricks can have strengths of up to 100 megapascals, although a common house brick is likely to show a range of 20 to 40 megapascals. Bricks are a versatile building material, able to participate in a wide variety of applications, including structural walls, exterior and interior walls, bearing and non-bearing soundproof partitions, the fireproofing of structural steel members in the form of firewalls, party walls, enclosures, and fire towers, foundations for stucco, chimneys and fireplaces, porches and terraces, outdoor steps, brick walls, brick walks and paved floors, swimming pools. In the United States, bricks have been used for both buildings and pavement. Examples of brick use in buildings can be seen in colonial-era buildings and other notable structures around the country. Bricks have been used in paving roads and sidewalks, especially during the late 19th century and early 20th century. The introduction of asphalt and concrete reduced the use of brick for paving, but they are still sometimes installed as a method of traffic calming or as a decorative surface in pedestrian precincts. For example, in the early 1900s, most of the streets in the city of Grand Rapids, Michigan were paved with bricks. Today, there are only about 20 blocks of brick-paved streets remaining, totaling less than 0.5% of all the streets in the city limits. Much like in Grand Rapids, municipalities across the United States began replacing brick streets with inexpensive asphalt concrete by the mid-20th century. In Northwest Europe, bricks have been used in construction for centuries. Until recently, almost all houses were built almost entirely from bricks. Although many houses are now built using a mixture of concrete blocks and other materials, many houses are skinned with a layer of bricks on the outside for aesthetic appeal. Bricks in the metallurgy and glass industries are often used for lining furnaces, in particular refractory bricks such as silica, magnesia, camut, and neutral cro-magnesite refractory bricks. This type of brick must have good thermal shock resistance, refractories under load, high melting point, and satisfactory porosity. There is a large refractory brick industry, especially in the United Kingdom, Japan, the United States, Belgium, and the Netherlands. Engineering bricks are used where strength, low water porosity, or acid flue gas resistance are needed. In the UK, a red brick university is one founded in the late 19th century or early 20th century. The term is used to refer to such institutions collectively, to distinguish them from the older Oxbridge institutions, and refers to the use of bricks, as opposed to stone, in their buildings. Colombian architect Rogelio Somalna was noted for his extensive use of red bricks in his buildings, and for using natural shapes like spirals, radial geometry, and curves in his designs. Starting in the 20th century, the use of brickwork declined in some areas due to concerns about earthquakes. Earthquakes, such as the San Francisco earthquake of 1906 and the 1933 Long Beach earthquake, revealed the weaknesses of unreinforced brick masonry in earthquake-prone areas. During seismic events, the mortar cracks and crumbles, so that the bricks are no longer held together. Brick masonry with steel reinforcement, which helps hold the masonry together during earthquakes, has been used to replace unreinforced bricks in many buildings. Retrofitting older unreinforced masonry structures has been mandated in many jurisdictions. However, similar to steel corrosion in reinforced concrete, rebar rusting will compromise the structural integrity of reinforced brick and ultimately limit the expected lifetime. So there is a trade-off between earthquake safety and longevity to a certain extent.